Here's another example. In this example, we are required to find the first four derivatives of this function and then write a general rule for finding the nth derivative of this function. Now, before I start working through it, I just want to go through some important definitions that will help us to work through this problem. So, I'm sure you remember what factorials are. So factorials are just products. And the notation is just an exclamation mark. So what do they mean? They simply mean to multiply a series of descending natural numbers. Okay. For example, if you have something like 4 factorial, it means the product will be 4 multiplied by 3 multiplied by 2 multiplied by 1. So these are just descending natural numbers and you're finding their products. So how about if you have n factorial? What that means is that the products will be descending. Okay, so that will be n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 up to 1. So back to the question. So in this question, we are supposed to find the first 4 derivatives. So the first derivative will be, and by the way, before I start working through the derivatives, we can rewrite this function. So y is equal to 1 over x can be written as x to the power negative 1. That way it's easier to use power rule. Okay, so dy over dx will be negative 1 x to the power negative 2, which can be written as negative 1 over x squared. The second derivative will be, we just need to differentiate this function here to x to the power negative 3, which will be 2 over x to the power 3. And we can continue this process up to the fourth derivative. So the third derivative will be negative 6 x to the power negative 4, which is just negative 6 over x to the power 4. The fourth derivative will be 24 x to the power negative 5, which will be 24 over x to the power 5. Okay, now remember what you're interested in is finding the nth derivative. So we want to find the nth derivative of this function. So what we need to do is to observe the patterns of these derivatives. So starting from here, we can see that the first derivative, we have a numerator of negative 1, 2, negative 6, 24. We also have these powers here, 2, and this is for the first derivative. Second derivative, we have 3. Third derivative, we have 4. Fourth derivative, we have 5. So that can help us to kind of generalize what the power of x will be. So we have little bits of information that we need to organize. So what I'm going to do next is to put all this information in a table. So on the first column, I'll have the nth derivative. On the second column, I'll have the numerator. And then here I'll have the power of x. Okay? So from our solutions here, we can see that for the first derivative, the numerator is negative 1 and the power of x is 2. So I'm just going to fill that information, and this is for the first derivative. The numerator is negative 1 and the power of x is 2. And then for the next one, we can see that the numerator is 2 and the power of x is 3. Okay, so here we have this is the second derivative. The numerator is 2 and the power of 3 is 3. The power of x is 3. Okay, so basically we can take all this information and represent it in table. So what we'll end up with is, for the third derivative, the numerator is -6 and the power of x is 4. And then for the next one we have fourth derivative, it's -20, the numerator and the power of x is 5. What you're interested in is to find the nth derivative. And obviously, for the power of x, you can see the relationship between these guys here. All through, you can see that the power of x is 1 higher than the nth derivative, which will be n plus 1. So for the nth derivative, the power of x will be n plus 1. How about the numerator? Now, here we have a few things that we have to organize. First of all, here we have powers of x, because this is the same as -1. We have powers of -1. So here we have -1. This is like -1 to power 1 multiplied by 1. And this is same as -1 to power 2 multiplied by 2 multiplied by 1. This is same as -1 to power 3 multiplied by 3 multiplied by 2 multiplied by 1, which is 6. This is same as -1 to power 4 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Now, if you notice, these guys here, these are basically factorials, okay? 2 factorial is 2, 3 factorial is 6, 4 factorial is 120, which means that our rule for the nth derivative will be -1 to power n multiplied by n factorial. Okay, so now we have an important rule for the power of x and the numerator, and we can use that to be able to write our general rule for the nth derivative. So the nth derivative will be equal to -1 to power n factorial over x to power n plus 1.